Hi, I'm Meta Spencer, and today we're going to Cambridge, England, and speak with Professor Peter Wadhams, who's my favorite expert on Arctic sea ice. Let's start at the beginning and tell people why we need to capture the damn stuff.
Well, the reason we really need to get rid of it is because it's a very powerful greenhouse gas. And although there's maybe only about a tenth as much methane in the atmosphere as there is carbon dioxide, that amount is very, very powerful. And so the total contribution of methane to global warming is something like 60% of the contribution of carbon dioxide, and it's growing. So methane is becoming relatively more important, even though we know that we're releasing huge amounts of carbon dioxide by burning things, but methane is growing much faster. And we think that the main sources of accounting for that increase is our own carelessness, that is the leakages from pipelines and natural gas operations, especially by the Russians, and then also the increase in consumption of meat in countries that have become newly affluent, like China. One of the big sources of methane is ruminants. That's cows and sheep and things that go on in their stomachs. And this sort of seems almost a joke, but in fact it accounts for about 40% of methane production. So the sources of methane are all accelerating, like everything seems to do these days, and we have to try and cope with that, because we want methane as a greenhouse gas is very, very powerful. Its advantage is that it disappears in about 10 years. If you release methane into the atmosphere, it oxidizes, and it's gone in 10 years. So if you have a single big burst of methane, it will do a lot of damage. You'll have a really severe warming effect, and then it will go away, unlike carbon dioxide, which stays forever. But if you then have a source of methane which is continuous, like, for instance, the Arctic seabed, where it's coming out and will come out with higher and higher intensity, then that we don't gain from its tendency to get used up. It just carries on renewing. So we really want to get rid of methane. And another threat that I think has most people kind of terrified is the thought that there might be a methane outbreak or a methane bomb, because one of the big sources of methane is the Arctic offshore, the continental shelves of the Arctic seas. And there the methane is contained in the sediments underneath the shelf, and they're kept in place by having a layer of permafrost on the seabed, which holds down the methane. And in shallow water, methane is unstable. You've got it contained in the form of methane hydrates, which are solids in the sediments. But as soon as you release the pressure over the sediments, the methane turns back into gas and comes out all in one go. So you've got this pressure cooker effect, where we're the pressure cooker, or rather the permafrost layers a pressure cooker lid, and that lid is busy melting away. And once it melts away, all that methane will come out.
You're saying that the permafrost in the bottom of the sea is melting?
Yes, it is. Yes, because the sea itself is above freezing point. In the past, the Arctic coastal seas were frozen all the year round. So the Arctic Ocean was a frozen ocean, and the Arctic shelves were frozen over as well. But now that melts in the summer the coastal seas melt. That's why you have this big area of open water around the center of the Arctic. And the area of open water, because the water depth is shallow, it warms up, and you can get quite high temperatures in the Arctic seas. I mean, I've measured 11 degrees in the summer, which is pretty warm. You can swim in that, and that temperature extends down to the seabed and warms and melts the protective layer of permafrost on the seabed and allows methane to escape. So that's the scenario of terror, that the methane will all escape in one go and will have a huge step change in global temperature.
Which is more, well, they call it a tipping point, but but it's a whopper of a tipping point.
Yes, it's more of a
it would be
catastrophe.
a catastrophe, which would probably be an extinction event, maybe.
Yes, well, I'm not hoping it wouldn't be an extinction event for mankind, but it would be for a lot of species. And well, we did an analysis based on 0.8. Based on a Russian estimate of how much methane would come out in one go if this permafrost layer thawed, and it would be something like 50 gigatons of methane. And we did an analysis of how much warming that would produce if it all came out at once, and it would be something like, we calculated 0.6 of a degree, and we wrote an article in Nature for that. But time passes on, and a new scientific group from the US Air Force did reanalyze this and reckoned with the same parameters that we used, you'd get a warming of 1.2 degrees, so it was double. And I think they're quite likely to be correct as well. They're using a better model than we used. And so this is really would be a terrific kind of step in global temperatures. It wouldn't just be the temperature rising steadily or accelerating as it does, but it'd be jumping. And that's what people fear, and so that's why they really need to find a way that can really get rid of large quantities of methane immediately. If there is an outbreak, can we mop it up? And that's what most people are worried about. Not how do we gradually diminish methane, but how do we clean up a sort of methane burst so that it doesn't do all these terrible things.
Okay, when you say a big burst, are you talking about like literally like a bomb kind of thing, instantaneous, or are you talking about over a period of a year? Or it's still, that would be extraordinarily rapid, but I mean, what are we facing here, and basically how much time do we have to solve it?
Well, we don't know how long, if we had a burst, how long it will come out for. I mean, it's being called a methane bomb, which sounds dramatic, but in the modelling work that people have been doing, they assume maybe it will take a couple of years to come out, because you've got to sort of disintegrate all the methane hydrate, which is a solid material. That's got to turn back into gas, and you've got layers going down hundreds of meters to get rid of. So it won't be instantaneous, but it will be rapid enough that we would sort of see the temperature going up, and year after year, and after 2 or 3 years, we would have a pretty large rise.
Well, I take it that you're of the opinion that this is a very real possibility, if not probability.
Yes, I think it's likelier than people think. Well, it's likelier than the Intergovernmental Panel on Climate Change thinks, because they really suppress suppress everything about methane. They really don't want people to know about it, even in case it frightens them. But it really is, I think, a serious threat, a serious danger that we ought to be trying to cope with before it happens.
Okay, before we talk about what to do, I just have to shake my head in horror that we can't trust the IPCC to be the bottom line, the real authority. We're told that at least trust science, don't believe crackpots. And I don't think these guys are crackpots, but we still can't believe everything we're told by apparently scientists. So this makes me want to cry. What's the matter there? Why would they be downplaying this risk?
Well, they always have with methane, and I don't know why. In fact, because they don't downplay other things. Well, they do, but not as much. And whereas methane, it's really quite it's quite blatant. I mean, I have personal experience of this because the people who were doing all the work on methane measurements in the Arctic were a couple of Russian scientists, and they still are the ones who do most of the work. Called
this Natalia lady.
Yeah, that Natalia Shakova and Oleg Semiletov. They've been going every year to the Arctic in Russian ships, observing these methane plumes coming out. More methane plumes each year. I mean, it hasn't reached a bomb stage, but it's increasing year on year. And they have lots of photographs and film of the methane coming out of the seabed, and absolutely clear that methane is a serious threat. But when they tried to publish their data, it was ridiculed and poo-pooed by a lot of scientists who should know better. And it's quite, well, partly it was that they were ridiculing it because of her, that as a woman scientist, they assumed she must not know what she was doing, and also the fact that she was Russian. And the people who were doing the ridiculing were people who actually work on methane, but don't work on it in shallow water. I mean, one of the most notorious is a British scientist whose name I won't reveal, but he's a real pain. And he studied methane coming out of the seabed off Spitsbergen and in various deep water places. Now, the thing is, methane does dissolve in water. So if methane comes out of the seabed at a depth of 400 meters or something like that off Spitsbergen, it will dissolve before it reaches the surface, and you don't get any sort of pollution from it. But if the methane's coming out in water depth of only 60 or 70 meters, which is what you get in the Arctic shelves, it doesn't dissolve in that time, it reaches the surface. But he was saying, oh, methane dissolves in water, so it can't possibly come out, so they must be wrong, they can't really be seeing methane coming out. I mean, that's an elementary error. It's an elementary failure to understand that methane takes time to dissolve. And he's not distinguished scientist, but he's a well-known scientist. So he had this prejudice against the work that they were doing. What's so difficult about methane that you have to keep quiet about it? It's a bit like, it's not like flying saucers or something. It's not like where there's some doubt about whether something exists. It definitely exists. So why suppress publications about it? And I found that happened to the Russians. It's happened to me. It happens all the time that the Intergovernmental Panel really downplays methane as a threat. And I think it's probably because it is a serious threat, and they don't want to frighten people. They want people to to be kind
Yeah,
of.
that is, of course, the answer for most. I mean, there is a field which I don't know much about as a sociologist called the Sociology of Disasters. And it's not something I've looked into at all deeply, but I know that one of the main findings is that when an authority figure is consulted about a risk, they always minimize it. Then, and the answer is they will say, well, something terrible might happen if we get people into a state of panic. We must not frighten people until we are absolutely sure that the risk exists, because the terrible things will happen if people panic. The reality is that it's very rare for people to panic. It's much more common for people to do exactly what you said, which is they themselves will discount the risk and pretend that they don't know about it. Denial is much more common. So you can go up and down the street with a bullhorn on your police car saying, run for your lives. There's a high dam that's about to break and you're going to be drowned. So get out of here instantly, and people will ignore it, you know. So that, and you have to actually do something terrible to get people to conform. You know, we had something like a gas leak, of train derailed in Mississauga about 40 years ago, and the whole community had to be evacuated quickly. But people would sneak in back into their houses because they didn't want to believe it was true, you know. Yes, there was this, I don't know, chlorine or something that was really put them at risk, but people will deny the whole thing. So I see this as probably the worst problem we face. It's not the methane. So I've got 10 different things that we might be able to do about it, but it's stupid people, you know.
Yes.
And that's what's, excuse me for ranting, but this is really my main preoccupation these days. Is we got to change people's heads, because our problem is not so much reality as it is stupidity.
Absolutely, yes.
Willed ignorance, you know, denial. Yeah. So anyway, let's move on and talk about the real problem we're going to face. What answers are available? If we took you seriously, and I pray to God we do, what should we do about it?
Well, as you say, there's about 10 different things, but that's not good news. I think when I gave a lecture on it, I only found 6 different ways. But the more ways there are, the less likely it is that any one of them is going to be the answer. And with carbon dioxide, it's really air capture, and that's it. So you know what you have to do. It's just spending the money to do it. But with methane, there isn't a simple way. So I can go through some of the ways that people have proposed. I think the first method is can we actually get rid of the methane by marine cloud brightening? I mean, you must have heard about this method from carbon dioxide removal, which is that you use a very fine nozzle, pump seawater up through a mast into low grey clouds, and they brighten the clouds up. And that means clouds reflect more energy, and that cools the climate. So this is a way of cooling the climate, or at least trying to hold it until we can actually do proper things like CO2 removal. But the person who designed that method, that Stephen Salter in Edinburgh, he did some work. Well, actually, I was a co-author with him on it, where we looked at why can we use marine cloud brightening in a targeted way to hit one particular region or limited region, not just to cool the whole planet. And so we looked at the Arctic and thought, well, what can we do to maybe refreeze the Arctic or encourage Arctic sea ice to grow? And we found that there are certain spots on the planet where, because of prevailing wind directions, if you put your ships there, the cloud brightening effect will have a maximum effect on Arctic clouds or Arctic.
Mm-hmm. I am trying to contact a man in Australia to interview him on a talk show about that. He has been doing, and maybe he's still doing, that with respect to the Great Barrier Reef.
Yes.
The Southern Cross University guy, Daniel Harrison. He goes there and puts these clouds over the Great Barrier Reef, and I don't know whether that's working or not. I want to find out. Do you know anything about it?
Well, I think it has been working. Yes, the Australians at least are paying to have this work done, where the British are not paying Salter anything to do his marine cloud brightening, which I'm going to complain about bitterly at the COP meeting. But the idea is, if you focus the cooling effect on a limited region, you can focus it on the central Arctic basin, where you can cause, at least according to our model, you can cause the sea ice limits to expand. So it's not refreezing a melted Arctic, which would be the best thing of all, but it's simply taking parts of the Arctic where you already have some ice and getting more to grow. And the more ice that grows, the bigger an area of sea ice there is, then the cooler is the water underneath it, and the less likely it is to provoke this methane bomb. The methane bomb is when the seawater warms up because there's no ice over it. If you can get some ice back over it, it will cool back down towards freezing point, and then that will keep the seabed sealed off, and you won't get methane released. So it's a sort of keeping the methane in its place method, and we think it would work, but of course it's not 100%. It's only going to do this in a certain part of the Arctic.
Now you say that it depends on whether there are winds that would blow the stuff away.
You have to, the models, you use really climatological winds. You're looking at what, where do you inject the finely divided water? Where do you inject it such that you have a maximum probability that the winds will carry it up into the Arctic? So it's a probabilistic model.
Okay. Well, you think this is the most promising thing. Well, there's another woman I was trying to interview named Kelly Wanser, and I was trying to schedule an appointment, but she declined to show up. I don't know whether well, she didn't give a reason. So Silver Lining is the outfit, and I don't know, it's going to be a commercial. It sounds like it's kind of a business or something. I don't know.
Well, it's strange. It is a business, but it's a business of helping people.
Yeah.
There aren't many businesses like that they have money to give out, and they'll fund research projects that look as if they might be good for climate change, but it's in a business environment. So I think they bring in donations or whatever from big business, and then they cut them up into bits and give them out to smaller projects.
I don't like to repeat the same thing over and over again, but the same information needs to get out there in various forms. Yeah. So I like to vary the number of people and the types of speakers and so on. Really, the important thing, I think, is to keep talking about it. Now, are you going to be making a pitch on this at COP?
Yes, I expect to. Yes, in fact, I've got a lecture that I'll be giving at the COP which focuses on methane and methane removal.
Well, do you have any prospect of being able to turn their heads around?
Well, it a lot. Well, I hope so, but a lot depends on what the hosts turn COP into, and the Italian hosts might be okay, but the British hosts are Boris Johnson, in whom one can have no faith whatsoever. I mean, he would treat it as a joke.
Well, yes, but he wouldn't be determining the content of the papers accepted, would he?
No, but the general direction of COP, and also the papers are at one level, but the political negotiations are at another level. I mean, we'll never be allowed into those, and so the political side is the important one, where they decide whether they're going to agree on improved targets for reduction of carbon dioxide. And that's where you're dealing with Johnson, and he's basically a clown, and he's a kind of a sort of like a Donald Trump with a sense of humour, which is not a great thing to be for the world.
Yeah. Right.
Anyway,
now, okay, so let's cover some of the other options.
Yeah.
Because I mean, people, I think really the problem is people are just so scared of anything that is called geoengineering. But I did have a very interesting interview with some folks, two guys. One is, I think, in Switzerland, and the other one's in France someplace. And they are using iron salt aerosol. At least they're not doing it. They're planning to do it. They don't even have their pilot study set up. So I think they're hoping to get some money to do it or something. But is that one that you would have on your list of 6 potentials?
Yes, that's going to be the next one on the list.
All right.
It's iron salt aerosol. It's interesting. The idea has been around for a long time, but nobody has had the money to try it out. And so there's been a foundation that I belong to who's been making the entire effort on iron salt aerosol, and which is called Restore Our Climate. And it in the end, they found it putting together enough money to do some experiments actually at the University of Copenhagen. And it does work, but maybe not as well as they hope. The idea is that one of the things that reacts with methane is iron chloride or ferric chloride, and so that reacts with methane to give you some harmless compound. So if you can get an aerosol of ferric chloride and you blow it over a place where methane is being emitted into the atmosphere, it will react with the methane and will destroy a lot of the methane. So this will be a way of getting rid of, say, methane burst from an outbreak or methane.
Okay, now I think these guys were hoping that it would be something that they could disseminate over large areas, that the whole, they want to put in towers or something around in the tropical areas. But it sounds like what you're suggesting is that they need to be more localized, like pretty close to where the methane is being emitted, so that concentration is high.
Well, the initial attempts are all doing it on a small scale, doing it near the surface. You can do it, for instance, by having your ferric chloride emitted from the funnels of ships. So you inject the ferric chloride into the outflow from the smokestack of the ship, and it then sprays it around the vicinity. And if there's methane being released, it will mop it up. So there's a case for having ships equipped with ferric chloride making machines, and then wherever they go, they can spread this stuff. But the tower idea, I think, is unrealistic. It's a branch of this ROC, which is a German group who want to build towers that are 300 meters high, it's 1,000 feet high, for some reason, because they want to release the ferric chloride from the top of the tower. And their reasoning is that will increase the effectiveness of this thing. But I don't see that it will. In fact, it probably, as far as I can see, reduce the effectiveness, because the sources of the methane are all at ground level or near ground level. So you want to combat it near the ground. You don't want to have something 1,000 feet up in the air.
Well, I think they're assuming that, once it gets past the local region, the smokestack or the rice paddy or wherever it's being emitted, that methane is pretty diffuse and constant in the quantity around the world. That, if whether you're in Peru or in Oslo, it's going to be about the same. Is that the case? And they were hoping that you could just, like ambient methane in the general atmosphere, could be knocked out with this thing.
Yes, I think that was their reasoning. And it certainly is the case that methane will get right around the world. And when you look at maps of methane distribution that you can now produce from satellite instruments, you don't see little nests of massive methane. It's diffused everywhere. And all you can say, for instance, is if you look at the world distribution of methane, it's higher in the northern hemisphere than in the southern hemisphere. So there's more sources of methane in the northern hemisphere than in the south, and that could it be explained by Arctic sources of methane, or simply methane produced from melting permafrost, or methane produced from leaks from gas pipelines, which are nearly all in the Arctic because that's the Russians. So we can say in general terms that methane will has a higher concentration in some places than others, but on the whole it does diffuse over the whole planet. And so it's true that if you really want to get rid of planetary methane, you do need to you can do it anywhere and at any height above sea level. Same as with carbon dioxide.
Yes, Adam.
Yes, I'm finding the statement you made about there being more methane in the northern hemisphere than the southern hemisphere very, very interesting. Is there a geological difference between what is under the ice in the northern hemisphere versus the southern hemisphere? And are we seeing methane plumes in Antarctica and the subantarctic islands, for example, anywhere near comparison to what's in the north?
Well, there are some methane plumes in the Antarctic. In fact, they've been observed near Antarctic ice sheet, near glaciers, and but they're kind of rare, and there's much more in the way of sources in the northern hemisphere. In fact, I've got one of my slides that I haven't got with me at the moment, I can show later, is a worldwide map of methane, and you see this. It gets more and more dense as you move towards the North Pole, and less dense in the southern.
Why?
Well, it's more sources in the northern hemisphere. The sources from the leakage from gas pipelines and leakage from the seabed from these methane outbreaks. Because although we haven't had a methane bomb yet, we've certainly got a lot of methane plumes coming out of the seabed, and the methane's coming out into the atmosphere.
Let me divert it a little bit back to where you were talking about methane from cows. I did a talk show with a guy named Mitt Lohner, I think something like that. He's a professor at Davis in Berkeley. And he is somebody really defending the beef industry, cattle, because he claims that the methane that's produced from cows, unlike that from emitted from the sea or other places where it's been stored, it's part of a cycle. It is emitted from the cow, it goes up in the atmosphere, and after a few years it's broken down, and then it goes into it is absorbed by grass, and the cows eat the grass, and then they emit it again. So he says that if you have the same amount of cows all the time, you're not going to get any additional methane. I guess the explanation for what you're saying is the increase in cows. It must be that as people are eating more and more meat in poor countries, that maybe the number of cows in the world is increasing. But he also shows a huge variation in the amount of methane being produced, that some in poor countries, especially Africa and so on, that they're emitting a lot more than they would here. So anyway, that's a side issue.
He does sound like a guy who eats a lot of steak. I used to feel the same. I mean, I thought, veganism is a kind of a weirdo type thing. But in fact, the more I read about it, and I'm being indoctrinated from various conferences I've gone to, where the people who gave the starring talks would then bombard me with books that they've written, and I must admit I am sort of converted, and it is true, in fact, what they say, that something like 40% of the greenhouse gases put into the atmosphere are from animals, from cows, the digestive processes in cows and sheep, and the fact that we use a lot of land for looking after cows, and which could have been spent used for growing plants, and their estimate is maybe 40% is too high, but 30% is quite possible. And so if everybody stopped eating meat, it really would make a big difference to global warming. It's probably the best thing you can do, that as one person alone can do, that would have an impact on the greenhouse effect, would be to stop eating meat. And of course, most people don't want to stop eating meat, and I don't want to stop eating meat. But if I really put the planet first, I would stop eating meat.
Mm-hmm. Okay.
But there's only one type of methane. There isn't sort of special cow-friendly methane. But there has been research done on, can we feed cows on something else that will mean they don't produce so much methane in their guts? And it seems that there's some species of seaweed that can reduce the methane effect in the cow. So if a cow eats seaweed of the right kind,
well, he's doing that kind of work, so he knows, he's the expert on that. I will send you the link to his show. I think it's a good controversy, and we're talking about. Let's go on and spend a little more time on these other. You say you have 6 potential solutions, but you're not happy about the probability that any of them will be really adopted, or what? Go on and tell me, what else are there? Well,
because not eating animals is one.
Okay.
But the iron salt aerosol is, I think, could be quite promising, and the experiments in Copenhagen on the whole worked, and we were hoping, but I'm not sure if we'll ever manage it, to because I do work some of the time with an outfit which is doing racing cars with racing electric cars, and they have a science support group that does scientific work in each of the places where they do these races. So it's I think it's a good idea, but anyway.
No, I'm confused. What are these racing cars doing?
Well, they're racing. So you race. They race in remote places, like Greenland and Patagonia, and and each time they race, they're electric cars. Each time they race, there's a scientific program to study what's going wrong with that part of the world. Like with Greenland, it's melting of the ice sheet, and so they couple the science to the racing, and the racing is of course thrills and spills. So I think it's a good idea. It's a British company, but founded by a Spanish guy, and the main asset they have, which I find interesting, is a ship, and they've got a ship which they use to take the drivers and the cars around from one set of races to another. So it travels worldwide, and it's used for oceanographic work while it's sailing from one spot to the next. And one of the things that we're hoping to do with it sometime is to do these methane reduction experiments by having ferric chloride emitted by the ship's funnel, and then inject methane and see how whether it gets rid of it or not. So that's one way in which we can test this iron salt aerosol concept.
Mm-hmm.
I think it's in terms of chemistry, it works. I mean, the reaction between ferric chloride and methane is a well-known reaction, and so it's not as if we have to discover some new chemistry to use it. It should work. So that's another method. Then other methods are: can we directly save the Arctic by thickening the ice? And that's where I think that's not going to work. There was a paper on it that was produced by a group from Arizona State University, not famous for their Arctic familiarity, saying, well, we can save the Arctic ice by thickening it, by pumping water over the surface, and then the water freezes and the ice is thickened, stays around longer, and we get colder Arctic. The problem there is that the energy required to pump this water over the ice is gigantic. You're trying. It's been done for single ice flows. The oil industry pumps water over a single ice flow to thicken it so they can put a drilling rig there. But to spread water over tens of millions of square kilometers, it's just impossible. And the Arizona group, because they come from Arizona, they envisage doing this using windmills, but it's not wind pumps as we understand them, but old Kansas style windmills as featured in The Wizard of Oz. And so that they envisage millions of wooden Kansas style windmills standing around in the Arctic pumping water over ice.
Okay, I think that the first thing that would occur to me was exactly your point, that it would take so much energy to put this stuff up there that what are you going to gain? But let me ask you about these. I heard of something about little glass beads.
Oh yes,
It's
yes. This is Leslie Fields. She's in Stanford University, and I don't really believe they'll work, but they haven't been tried properly yet. And I know her quite well, and I'm always encouraging her because she's very serious and minded and really takes this thing very seriously, but has never yet managed to accumulate enough glass beads to test whether it affects the climate. The idea is that it's really a bit like marine cloud brightening. We want to brighten or whiten the Arctic, and if you whiten it, you increase the albedo, and it will cool it. So her idea is to use tiny glass beads and spread them all over the Arctic, and hope that would increase the albedo. The first thing immediately that you think is could be very, very dangerous. I mean, if they're tiny beads, and they're going to get into the stomachs of fish.
sure.
Not to mention the stomachs of humans that eat the fish. So that's going to be very dangerous. And that, to me, is enough to wipe it out, pretty much.
Yeah.
But she's been doing them with Alaskan lakes, and does get an effect. But you have to scale up again. The difficulty with getting rid of methane is always the scaling. You have to scale everything up to sort of 10 million square kilometre level.
Yeah.
So you can't make enough glass beads. Well, if you did, the factory that makes the glass beads would be emitting huge amounts of carbon dioxide in its glass bead production, which would be far more than you gain by spreading them.
Well, I assume that is not on your list of 6. How many others? What have we covered? About 3. Let's move on to what do you think are realistic.
We're getting into unrealistic ones now.
Yeah.
But I should consult my lecture, because I kept discovering new methods that I then included in my lecture and then forgot about again. But I would say iron salt aerosol might be the answer, or might not. Whereas we know that marine cloud brightening is an answer, but it might not do enough brightening or brighten up enough area to enable ice to grow to the point where it gets rid of this danger of
well, I asked Stephen Salter what would be the potential negative effects of this, because you have to look at what are the risks. And of course, I guess you can't really anticipate all the possible outcomes, but he said that it might cause more rain in certain areas. But the advantage of doing this is that you can stop doing it and stop the effects very quickly. It's not like there are going to be prolonged consequences of rain going on for years that once you started it, you couldn't stop. So, but on the other hand, I guess if you're going to invest all the money to get the thing going, you don't want to have to turn it off in a week and say, oh, not a good idea. So then I would wonder, what are some of I didn't ask these other fellows who were running the iron salt aerosol plan, but I wonder if you know if there are predictable negative effects of that.
No, there aren't any sort of known drawbacks at the moment. I suppose the only thing is the ferric chloride, when it reacts with methane, you get some kind of ferric salt, which falls out and covers the ground or the sea surface or whatever. And I don't know whether anybody's looked at whether that's dangerous or poisonous or what have you. But at the moment, it looks like a relatively benign method.
Do you know whether those salts would increase the phytoplankton? Say it falls in the ocean. Now, one of the things that Paul Beckwith was promoting when I talked to him 3 or 4 years ago about, or less actually, was the idea that by sprinkling iron salts, you could increase phytoplankton, which would capture CO2. This was not methane, but CO2, and then fall to the bottom of the ocean and sequester it. So, and it would also give good food for more fish in the region. But now he's talking about iron filings. I don't know whether these iron salt deposits or whatever would be the fallout, whether that would have any effect on the phytoplankton or the ocean ecosystem.
No, it's a different scale. The iron filings method that has been tried and it works. There was a guy called, the most famous person who did it was called Russ George, and he committed the unpardonable sin of making money out of it. He was hired by a local Indian tribe in the Queen Charlotte Islands in British Columbia because their catches of salmon were very low. And so he seeded the seas around these islands with masses of iron filings, tons of the stuff. And they got a record catch of salmon. So the Indians were really pleased. It worked. And the Canadian government wasn't pleased because it had worked. How dare they do something that works? And they confiscated all of his equipment. And
why did they object? Why shouldn't they be celebrating?
Well, it's the not invented here syndrome, that the Canadian government hadn't been able to do anything to help these Indians, so they didn't want anybody else doing anything, otherwise it would show them up.
You have a cynical worldview, but I have to share it half the time.
Well, anyway, he was propelled away and not allowed to do any more of that. But the technique has been tried. In fact, there's been 14 experiments with this, and they've mostly worked. So the trouble is that very often you put too much iron in, and the iron filings are quite expensive in mass. And if you put too much iron, then you get a huge production of plankton, and then the plankton dies off, and you get this poisonous red tide, which you sometimes get around the coast of Florida, which is dead plankton. And so you have to calculate the dose really carefully so that you get enhanced growth of plankton, enhanced growth of fish, and not so much that you kill them off. So
now, is that the same as eutrophication?
It's sort of the same thing. It's eutrophication is where there's an absence of oxygen, and this you get an absence of oxygen because it's all been used up by the growth and then decay of the plankton. So it's meant to be a method of increasing fish yields, and so you use a lot of the methane of the iron. But the iron salt aerosol, you only use a tiny amount, just a couple of pounds of iron will do an ocean. It's a really fine aerosol, and it's because you're puffing it through the atmosphere, and you're getting it to react with the methane, and that happens. You don't need much iron to do it, because you're not with iron seeding, you're having to increase the iron content of the whole surface layer of the ocean, which is huge amounts of iron needed. But here, all you're doing is in the atmosphere, you're producing a level of iron chloride that will will react with methane. So it's better in that sense, and the amount of iron that ends up on the floor, so to speak, is trivial. So I think that makes it a good candidate. But I'd like to see a lot more experiments done first.
Well, can you lobby the right people at COP? What has to be done to set a fire under some of these guys?
Well, it is a fire that's needed because everybody, even IPCC, now says the danger is now, the threat is now, the awful things are happening now, the fires and are happening now. Everything's happening now, not in 20 years' time, which is what we used to think. So the IPCC has sort of repented of saying, well, in 20 or 30 years' time, we should reach these goals. We have to do it now. And so everybody really wants to find techniques which can be immediately applied. So that puts a sort of urgency into it all. And so that there is a slightly increased hope of getting some action now.
Do you think, from what you know about John Kerry, do you have any hope that he is more ambitious than anybody else in the U.S. has been so far?
Oh yes, I think he's very impressive. I've met him a few times, and he really does. Not only does he want to do something, but he knows what to do. He knows what things are the priorities. And it's great that he's been put in charge of the climate program because he.
Well, would he do anything as remarkable as? I mean, you were talking about these chimneys and need research on what happens there and so on. And would he do anything as bold as start up a project to do cloud brightening or the iron aerosol thing?
I think he would. In fact, there's already been quite large amounts of money put into various projects like that in the US. And it's only recently that it's been done, and so results haven't come out of anything yet. But there is a big increased level of research. People who never used to get any money to do anything are now getting research money and doing things.
Mm-hmm. So I'm really glad that I'm much smarter than I was an hour ago. So thank you very much. Appreciate it.
Thanks very much. Yeah.
Take good care. Okay. Bye.
Bye.